In this video, we're going to go over some questions covering Newton's first law. So the first one is, you should know what Newton's first law is. And in most of physics, you can get away with not memorizing the equation. You're almost always going to be given an equation sheet or a cheat sheet or something. But Newton's first, second, and third laws are the guiding principles. At the very least, you should be able to memorize them just so you know them. And really, knowing them off the top of your head is tremendously important. Order doesn't always matter, but I found it can be kind of helpful. So the first thing you should do is write out Newton's first law. So let's do this together if you forgot what it is. It's an object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an external force. And I abbreviated it a bit there to make space, but that's the key concept. If it's moving, it stays moving. If it's stopped, it stays stopped, unless there's an external force on it. So now we're going to do a quick quiz where I give you some examples, and you say which are examples of Newton's first law and which aren't. So for each of these scenarios, you either need to say yes, it's an object either in motion, moving in a constant velocity, or at rest, staying at rest, with no external forces acting upon it. And some satisfy that definition, some don't. So pause the video, take a second to go through it, and then we'll go through it together. So let's look at these. A car moving at a constant 60 miles per hour. It's very tempting to say, yes, this is accurate. But let's think about this. Our car, which is going along, and forgive the bad drawing of a car, has frictional forces pulling backwards on it, and the person driving is pressing on the gas, causing the car to go forwards. So the forces cancel out, but there are external forces. So no, this does not satisfy the first law. A satellite in a circular orbit. Same deal. It's very tempting to say that our satellite, flying along, let's make it Sputnik, there's nothing pushing on it. There's no air resistance, we say there's no gravity, so it's good, right? Except no, hang on, there is gravity, and it's causing it to accelerate. And based on the fact that it's not going in a straight line, you can say no, it is accelerating, so there is an external force. But now what about an asteroid in deep space? Now our little friend the rock's just flying along. He's going in a straight line, there's nothing to run into, he's too far away from anything for there to be noticeable gravity. So yeah, he does fulfill this definition. He's in motion, and he's going to continue in motion until acted upon by an external force. Now what about a rock on a merry-go-round? It seems like maybe, right? The rock's staying still, it's not going anywhere. But like the satellite, it's on the merry-go-round. And if you trace out its path, even though it seems like it's staying still on the merry-go-round, it's moving relative to the Earth. So no, it doesn't satisfy the definition either. But a rock on the ground, well, that's good. It's just floating along in the same trajectory as the Earth. The Earth travels, it travels. There are really no major forces acting on it. It's just sitting there. So it's good. So what we can see is examples 2 and 4 both dealt with rotational motion, so they were no good. They failed the definition. Number 1, it was moving at velocity, but there's an appreciable amount of friction slowing it down, and an appreciable amount of energy going into speeding it up. So it failed also. Whereas the 2, one where it was just going along on its own, and one where it was just sitting there on its own, both were traveling in a straight line or staying still, which are the 2 hallmarks of something obeying Newton's first law. So hopefully you now have a solid understanding of Newton's first law, and are ready to be questioned on the second law.